According to a story that makes you sit up and take notice, scientists have discovered a previously unidentified black hole in the massive Melonic cloud that seems to be headed straight toward the Milky Way. This finding is particularly noteworthy, since the gravity monster falls in a seldom-seen mass class and is likely to fuse with Sagittarius. Our home galaxy's black hole is a star, but how will the strange object affect the Milky Way in the future? How long do we have left until then? How did the experts find the mysterious giant? What might initially seem like the plot of a dramatic Hollywood film is actually nothing less than an astronomical reality. According to a recent research published in the Astrophysics magazine, a gigantic black hole has been discovered near the Milky Way, hurtling directly toward humanity. We have not yet seen this extraordinary guest because black holes are difficult to detect directly. Instead, scientists rely on telltale clues like their intense gravitational pull, which may propel other celestial bodies to unimaginable speeds. Naturally, this potent feature of black holes was also known to the team headed by astrophysicist Joanne Jessie Hahn from the US-based Harvard and Smithsonian Center for Astrophysics. As a result, when the experts examined a group of incredibly fast stars in the Milky Way's periphery, known to the scientific community as hypervelocity, the influence of such a massive monster was also mentioned as a significant contributing factor. The stars, the stellar speedsters, had been tracked down by the European Space Agency. Gaia Space Telescope this recently completed its scientific service and previously surveyed the entire sky in 3 dimensions, with great precision also uncovering 21 unusually fast stars that immediately became the focus of astronomical interest. This is no wonder, since from the outset there was speculation that the objects could look back on a truly eventful past. More specifically, this refers to the assumption that the stars originally belonged to binary systems that ultimately came close to a black hole. In this case, a process known as the Hill's mechanism can occur, and means nothing more than that the pair of stars are torn apart, and one of them is hurled at high speed into the depths of space. In fact, stellar travel speed can be increased to over 1,000 km/s in the process, but to be sure that such a fate has befallen the celestial bodies, scientists have to reconstruct their orbits under the origin, and excitingly, the researchers have succeeded in doing so in 16 out of 21 cases, and since 7 of them come straight from the center of the Milky Way, where, as already mentioned, Sagittarius, additionally there is a star there, which suggests that they were really victims of the Hill's mechanism. However, the analysis of the star cluster's remaining 9 stars revealed even more unexpected results. The reconstruction of their orbits revealed that they did not originate in the Milky Way at all, but in the large Melanic cloud. How the experts found the approaching gravity monster contrary to initial assumptions. The large Melanic cloud is not a colossal cloud of dust or gas, but an independent galaxy that ranks 4th in the size chart of our local group, located just under 165,000 light-years from the solar system. This galactic cluster is known for the high level of activity of its young stars and old star clusters, but that's not all. The large Melanic cloud is also moving slowly but surely towards the Milky Way, and experts assume that it will merge with our home galaxy in about 2.4 billion years. But could the discovery of the fast stars be related to a black hole in the large Melanic cloud? Well, that was precisely the question the scientists also asked themselves when they examined this scenario in a simulation. More specifically, the researchers analyzed what would happen if a gravitational monster were to tear apart a double star system there, with the exciting result that the velocities and positions they calculated corresponded amazingly with those of the celestial bodies actually observed. In particular, a star cluster in the constellation of Leo was correctly predicted by the model, and since other causes such as supernovae were excluded. In further analyses, only one explanation remained: the influence of a black hole with a mass of about 600,000 solar masses. This mass is unique because it pertains to a very specific class of objects that are rarely observed in detail. It oscillates between supermassive black holes, which have masses millions or even billions of times greater than our mother stars, and stellar black holes, which have only a few solar masses. However, when and that is the key question: is whether we are truly in danger of a collision because, as was previously mentioned, the large Magellanic Cloud will collide with the Milky Way in the future, making it inevitable that the black hole will also come close to our galactic home. The good news is that, of course, the gravity monster will not overtake its galaxy, meaning that we have at least another 2 billion stars left before this strange visitor shows up. This gives us enough time to investigate the object further. By that time, because if the scientists' observations are validated through additional follow-up research, we will have discovered one of the closest black holes of this magnitude ever. In this case, Sagittarius. We only know of one black hole, a star that is even closer to us and sleeping right under our noses here on Earth. As a result, future studies may provide us with crucial new information about the mysterious world of the mass monsters, and provide us with detailed information on how the structures evolve over time, including the first dormant black hole outside the Milky Way. However, examining the findings of other studies on the massive Magellanic Cloud, we find that the scientists there have also discovered another black hole, which grabbed headlines right away. Almost 3 years ago, the news was reported that experts had discovered an inactive black hole outside our galaxy for the first time. But why is that so special? Well, on the one hand, it's because the object with just 9 solar masses belongs to a class that is very difficult to detect anyway, and on the other hand, it's because, contrary to the usual pattern, it did not arise from a supernova step. Black holes are formed when a massive star reaches the end of its life and explodes off the cosmic stage in the process. The core of the star also collapses and forms a stellar black hole. But although on paper there should be millions of such objects in the Milky Way alone, astronomers have so far only been able to directly detect a few of them. This is because stellar black holes usually only reveal themselves when they actively suck in matter. For example, from a companion star, the corresponding material then releases high-energy X-rays, thus revealing the presence of the invisible partner. The crux of the matter, however, is the fact that most stellar black holes are likely to be inactive and therefore do not even reveal themselves in the X-ray range. But how can such an object be detected at all? Well, that becomes clear when we take a closer look at the exciting discovery made by the team led by Thomas Scharner of the Belgian Catholic University of Leuven in 2022. To uncover the invisible inactive black holes, the experts targeted the so-called Tarantula Nebula in the large Magellanic Cloud, which is known for its many massive stars and double-star systems. In the course of this, the researchers specifically searched for stars whose movement could be linked to the existence of an invisible heavy partner. In this way, with the help of the Very Large Telescope in Chile, they finally managed to identify a hot bluish star with a mass of around 25 solar masses that exhibits conspicuous periodic movements in detail. The stellar motion pattern indicated that the celestial body has a hidden partner and that the duo orbits around each other approximately every 4 days, and since the counterpart was not visible in the spectral data, the experts were able to rule out the possibility that it was an ordinary star or another more luminous object. However, the same data indicated that the companion must weigh at least 9 solar masses, and thus is on the order of a small stellar black hole, a stellar black hole that was formed without a supernova. Not only does the VFT's 243 system contain the first known inactive black hole outside of the Milky Way, but when the researchers looked more closely at the system, they were shocked to discover that both celestial objects' orbits appear to be nearly circular. This is unusual, to put it mildly, because when a stellar black hole forms during a supernova, it actually receives an extreme shock that pushes it onto a highly elliptical orbit. In other words, the circular orbit suggests that the black hole, in this instance, was formed without a supernova. But how is that even possible? Although scientists have not been able to find any evidence of a previous explosion, they have discovered that the primary star of the system is already following in the footsteps of its invisible partner and is likely to turn into a black hole within the next 5 million years. That means that all that will be left are 2 gravity monsters orbiting each other closely and eventually merging into a new black hole. In fact, astronomers have discovered a number of clues that some stars can skip the final explosion and collapse directly into a black hole, and it appears that this is what happened to VFT's 243. To ensure you never miss another video from us, please hit the thumbs up and subscribe. We hope to see you soon.